Ben should be live.
Yeah, I've got you there, Joe. Can you hear me okay?
We can hear you, Ben.
Wonderful.
Okay. Oh, look, we can see you, Ben.
Yes, no, I can assure you that the accommodation in West Wyling is first class. So anyone looking for a holiday, I can make a couple of recommendations. Yep, even got my own bathroom. Fantastic stuff. So.
Awesome. Okay, Ben, I'll leave it to you to talk about our ag tech and what's coming next.
Yeah, thanks, Joe. So look, as has been mentioned, wanted to get you something, even though I'm interstate, and you know it's always dangerous when you're talking about ag tech to rely on technology, but that's what we've done. But to make ourselves a little bit safer, I suppose, we have done a pre-recording so you can hear the audio okay. So I think the team there are going to play that for us, and I'll be joining you at the end of that presentation and happy to take any questions. So let's see how we go.
G'day everyone, Ben White here, coming to you virtually. Unfortunately can't be there today in person. I'm doing some work in the eastern states, but we've also tried to take out the gremlins of technology and pre-recorded this so that hopefully you can hear my audio nice and clearly along with the slides, and I'll be jumping on a call and happy to answer any questions at the end. So if you think of something or you want to ask a particular question, jot it down and we'll certainly take questions at the end of the presentation. So the topic today is a bit of an ag tech update, and I wanted to have a look specifically at what's potentially around the corner. So I wanted to try and keep things pretty succinct today and look at just 4 technologies that I think are probably going to make a difference in the not too distant future, and certainly they're technologies that I know some major OEMs are working on at the moment, and I can see that you know, some of the components for these developments are really starting to come together, so it's just a matter of time for those to be integrated into either current systems or to be integrated with each other to form new systems. Now, I'll be weaving in some information from what we saw at Agritechnica 2019. It seems a while ago, but it also seems quite bizarre that you could have 500,000 odd people wandering through 32 hectares of halls, like full of machinery and equipment, on a 65 hectare site in central Germany. Now, there's 3,000 odd exhibitors, more than half of those are international, and included in those exhibitors are also some of the component manufacturers as well, which I think is where we see some interesting stuff, and we also get a bit of an insight as to what you know, the larger OEMs are demanding of those component builders. So we'll kick off the 4 topics, and the first one being electrification. And I often get asked about electrification and when we're going to see battery-powered tractors, and you know, when everything's going to go electric. And look, I can tell you that there's a bit happening in that space, but it's also, I guess, tempered with the fact that we don't have fantastic power grids, and you know, it'll take some time to work out, I guess, some of the solutions to integrate our current, I guess, limitations in infrastructure with, you know, some of the technology that's coming in the pipeline. So from an electrification perspective, one of the things we saw at Agritechnica in 2019 was a really big push for electric wheel motors. So, you know, electric hubs, electric drive systems. You know, there was a few themes, I guess, from Agritechnica 2019. Sensors and vision, electric drives, and battery tech evolution were all 3 things that we sort of saw when we were there. But as you can see, we've got, you know, electric wheel drives from the likes of Danfoss, the likes of Bosch and ZF, and of course John Deere as well. So you know, quite a bit of action in that space, and certainly something that should give us a bit of an insight as to what's up and coming. So the first question is really, what do we want electrification for? And ultimately, electrification or electric drive lines provide us with ultimate control. We've got 100% torque at 0 RPM, and that might help us with what we're going to talk about next, which is automation. But let's have a look at where we're at with battery powered or you know, electric powered tractors. And we've had John Deere come out just recently and say that they're going to be here in I think it's 2026 with a battery powered tractor. Admittedly, the small sort of format for horticultural purposes, but also we've seen something similar come out from Fendt as well in that 100 sort of horsepower category. Now, The fence pretty small, as I said, about the equivalent of a 100 horsepower tractor. It's got a recharge time up to about 80% with a fast charger in 40 minutes, and I think in about 5 hours it gets to 100% charge. So all electric drives, you've still got the hydraulic systems there that are integrated, but the charging side of things is interesting in that they've obviously got the high capacity charger that you might see on some electric vehicles as well, but also you can then utilise some of the electric power from the tractor for other implements. Now, we've also seen electrification of drive lines, and I suppose from the likes of John Deere, we've seen what they're calling an EVT. Now, people might be familiar with the IVT, which is the infinitely variable transmission. The EVT replaces some of the hydraulic components in that drive line with electrics. So we have a little look at the video here from Deere. You'll see that the two main driveline components that are swapped out from hydraulic to electric sit in the center. They'll be highlighted blue.
Electric motors take the place of hydrostatics to deliver seamless and precise performance, plus improved reliability and efficiency compared with other transmissions. The EVT is the industry's only transmission that can enable electric power generation of up to 100 kilowatts. In the future, you can use this electricity to power implement fan drives, or assist the tractor by powering up the implement's axles to reduce wheel slip, improve uphill performance, and pull wider implements without the need for extra ballast or a larger horsepower tractor.
So a couple of things that are interesting there, and one of which is that the electric drive system can also be used to power implements, and that could also be wheel drives. So what we're talking about is not only the tractor pulling an implement anymore, we're talking about the implement also driving itself. So having some sort of drive line, which hopefully, as we talked, or as you heard there, may reduce the need for ballast and potentially bogging, and it might get us out of some tight spots where we're carrying heavy loads. And I'm thinking of things like air carts and also sprayers. So as you can see, that's going to be available on MY23 410 horsepower 8R, 8RT and 8RX tractors. So this tech is well and truly on the way, and that 100 kilowatt generation is something we've actually seen before. So in 2017 at Agritechnica, we saw this Fendt X concept, which sandwiched a genset in between the engine and the transmission. So it still utilised those components as a normal tractor, but also had this genset sort of sandwiched between, which had 480 volt architecture, which is interesting as well because it seems to have become a bit of a standard. But the X concept was interesting in that they actually had a demonstration there with a few different implements of the power being used to drive those implements, and also suggestions that it might be used for electric wheel motors. So this probably was one of the precursors to what we're seeing come out today. So at the back of the tractor, in lieu of hydraulics connecting implements, you can see here a big orange cable which is effectively plugged into the back of the tractor, and that's utilising the power that's generated by the genset. And just to demonstrate the use of that 480 volt architecture, here's the Fendt X concept, plug in the back, down to a hay rake. So the linkage between autonomy and electrification gets a little bit more clear when we see companies like the Autonomous Tractor Company, which are based in the US, moving away from their focus just on building an autonomous machine, which you can see on the left, that's been around for quite a few years, to what you see on the right. And what they're actually doing now is their primary business is actually taking the likes of SP sprayers, ripping out all the hydraulics and putting electrics into these machines. So electric wheel motors, electronic transmissions, and a 250 kilowatt generator there to drive the machine along. So they're applying what they've learnt and what they've needed for their automation side of things, and are applying it to existing machines. Now, one of the things we've got to be a little bit careful of when we get into this technology space is the marketers. They tend to have a pretty good time. They tend to tell us a few things that might not actually be totally, let's say, straight. And it's illustrated by this fantastic machine that you might have seen in various press and whatnot around the place. So this John Deere track unit, Josh and I were crawling all over it. We're trying to find where the power source is there. Couldn't find it anywhere. Discovered that this video that they were playing at Agritechnica, obviously it drives itself along. There's got to be something there that's driving this. And at Agritechnica, there was a couple of people hanging around there. There was the marketers, and then some of the technicians as well. And so the technicians typically wore the silver jacket. So we spoke to this guy in a silver jacket, and we said, "Look, what's going on with this machine? We can't work out what the power source is." And then we found out that the tractor actually had something a little like this on the front. A dirty big cord, which, as you can imagine, doesn't always go well with the likes of tillage implements, as we've seen there. So that left us scratching our head a little bit, and thanks to the marketers, we were probably asking ourselves, now, electrification has been applied by a whole stack of manufacturers, and including Steyr as well. So we're going to probably see, in my opinion, diesel electrics before we see battery-powered tractors. So probably keep an eye out for more developments in that space. So let's move on to autonomy. As I said, it's pretty closely linked to electrification, purely because it gives us quite a bit of control over driveline systems. Now, I've seen a whole stack of manufacturers get into this automation space, and ultimately, as I said, electrification assists autonomy, and that's illustrated by this unit, which Class are partly involved in and have made an investment in. It's called the Ag Exceed. So we're talking about 156 horsepower prototype. This is on diesel. It's a diesel electric on tracks, but can also be purchased on wheels as well. Standard wheel track spacing, anything up to 3 meters or 3.2 meters, I think it is. So a reasonably flexible platform, and one to probably watch when you've got the likes of Class backing it. Now, autonomy is definitely already here, and we've got the likes of Swarm Farm, which are available for a whole range of stuff. I've seen it pulling turf lawnmowers. I've seen it doing selective spraying, as it is here. And the Swarm Farm journey continues to evolve. The guys are up to about their 29th machine out in the field now. It's a slightly different ownership model, if you like. Here we're seeing the automation paired up with selective spraying technology. And of course, it's not just the smaller manufacturers. We are seeing a lot of the major OEMs now coming to the party with automation, such as the demand. So there's some big players operating in this space, and expect to see quite a bit of investment and certainly a lot more availability as time goes on. So here's the 8R from Deere operating completely autonomously. No one in the cab, but of course any of these machines require eyes and ears. So the eyes in this case on the Deere autonomous platform are the 6 cameras mounted at the front, just above the weight stack there, and then also at the rear of the cab. So that does a couple of things. That gives the tractor eyes so it can detect obstacles in front of it and stop if required, but also gives remote operators the opportunity to tap in and see what's going on and check the machine performance. So obviously connectivity is very important, and that's something that's going to be really essential for us when we get down the automation path. So the evolution of automation is being driven pretty hard by the major OEMs, smaller OEMs, as well as the researchers. And pretty much any university that's operating in an ag tech space has got its finger in an automation pie somewhere. That list probably continues 3 screens down. It's absolutely huge. So the amount of investment and I guess effort in the automation space is pretty massive. So the other thing I wanted to talk about today was input application precision. Now, inputs are getting increasingly expensive, whether that's fuel or fertilizer. We need to be as precise with application of inputs as we possibly can and get maximum efficacy out of those. Things like chemistry, we know we can do a lot better job. So let's have a look at some of the technology that's starting to evolve in that space. All right, so let's have a look at the first application, and obviously green on green selective spraying is the first thing that comes to mind when we talk about being precise with inputs and potentially saving ourselves a fair bit of money. So this is a bilberry system spraying ryegrass out in canola. And if we have a look here, this is also green on green. This is spraying broadleafs out in cereals at 24 k's an hour. So if you have a look at the screen on the right, have a look at down the bottom of that monitor, and you'll see the green weeds sort of feeding in to the system as the cameras detect it, and then obviously triggering the sprays. Again, this is a bilberry system, green on green, as I mentioned, broadleafs in cereals. So let's have a look at some of the players in the green on green space. We've got the likes of bilberry, as I've mentioned, and those two examples that I've shown you have come from them. They're working with both Goldacres, Miller, AgriFac, and they're continuing to evolve the algorithm development, and also that means that they're looking for different weeds in different crops, and that will continue to evolve. So utilising the same technology, it's just a matter of getting the algorithms right to pick up the weeds in a given environment. John Deere See and Spray Ultimate, adopting the Blue River technology they bought a few years ago, are currently doing green on brown and green on greens here now for soy and cotton crops. And I expect in the not too distant future we'll see other crops and other weeds pop into the algorithm space there for John Deere. Quite small cameras on their booms, a lot more numerous, I suppose, than some of the other systems. We've got Hardy Geo Select, so using pretty high resolution cameras to pre-fly a paddock, detect the weeds once that data has come in, or once that imagery has come in, and generating an application map, and then allowing sprayers to go out and target particular weeds with particular herbicides. And then of course we've got another an XL Group, as is Hardy already, but they've also got the 3S spot spray system, so that's from Exact Robotics. So they're talking about spraying working day and night in ground speeds of up to 25 k's an hour. Also, we saw at Agritechnica a few years ago, and it's continued to evolve, this Bosch BASF Amazon setup, the Zavio, which can run a couple of different spray lines, detecting different weeds in different crops. We've also got the green on green from Carbon Bee, which is the eye spray, and so they've got backing of a major OEM in Kuhn. Green eye technology, another one. There's a stack of these things starting to evolve, and what that tells me is there'll probably be some consolidation and sharing of technology at some stage, which would be great for the end user. And there's a stack of others as well: Optronium, Techamec, Amazon, and Garford, which is actually a mechanical setup. So look, continue to see these selective spraying setups, and I imagine that with time, as I said, some of the technologies will be integrated and also perhaps consolidated into a more standardised format. We've also got Open Weed Locator, which is from Guy Coleman, working in that open source sort of space. And I think what Guy's doing here is really great. It means that anyone has access to the technology that's developed, and you can see his developed spray system here, top left-hand corner. And I suppose the other point that we make with any of this sort of technology is that while that's being used to spray, potentially has the option of integrating other technologies, and that might be the likes of laser. And it's always great to see literally weeds smoking dead. And if nothing else, this tech gives will give farmers great joy and warm the cockles of their hearts seeing smoke rising up off weeds that have been destroyed by laser. Nothing better. And with fertiliser being so expensive, making sure that we've got application rates right is obviously pretty important. So this is a piece of technology from Amazon, and what they're looking at here is measuring the amount of material falling on the spinner plates 200 times a second, in fact, and adjusting the gate every 25 kgs of product delivery. And what that means is that they get a pretty good idea of exactly how much product is going in the paddock, and also making sure that if there is too much going on, that the gate is adjusted to get back to the target application rate. So in addition to application rates, we also need to make sure that our spread pattern is correct. So here's some active monitoring technology from Kuhn, which is also used by their sister company Rauch. And they've got 27 radar sort of set up on each spinner to measure the speed and trajectory of particles as they exit the spinner plate. And what's cool about that is it gives them the ability to adjust a drop point, and that can happen every 4 seconds. There's also systems that are integrating weather stations and looking at prevailing winds, which might mean that they might adjust both the spinner, either spinner vanes and or vane angles to accommodate perhaps crosswinds. So we saw some of that from some of the European spreader manufacturers, which is pretty cool technology. And so we move on to our final point, which is machine format diversity. And what I'm talking about here is looking at different machine formats for different jobs, thinking a little bit outside the square as to what we do currently, in the same way that we've seen manufacturers think differently about automation, and they've utilised different sort of scales or platforms, I suppose. Let's have a look at what some manufacturers are doing in this space to make sure that the machine that we're using is the most suitable for the job at hand. So task suitability is what this is all about. And so in some instances, we might see small formats of, let's say, swarms, whether it be tractors or smaller units like drones, employed to work together to apply product or perform a particular task in the most efficient way possible. So what we've got here is a couple of examples of swarm machines. The bottom left is the little Fendt unit that's specifically just for seeding. We've got the swarm farm tractor up the top there, the robot that can be used for everything from spraying to spreading. There's talk of seeding and tillage as well in sort of small sort of format arrangements. And down the bottom you've got the T20 swarm drones. So all examples of where we've got small machines working together collaboratively to get the job done. Now it's at this point I've got to tell you about this machine that I walked past in my 6 years at the University of Southern Queensland. It was at the entrance to the engineering building, and we looked at it every day, and it continued to gather cobwebs and a whole heap of dust. And what we're talking about here is what's called a gantry tractor. So the idea with the gantry tractor is that you minimise compaction. It was a concept that sort of floated around in the 50s, 60s, 70s. And it continued to evolve, but never really got there. That's it until quite recently. So this is the Nexat. It's a 14-metre track centre gantry machine, effectively a toolbar that a whole heap of stuff can bolt to. So whether that's tillage equipment, sprayers, harvesters, as you can see here. The Nexat's been developed, as I say, as a toolbar. And I dare say that there'll be a stack of other implements designed and built that'll complement the Nexat sort of format in the future. So what we're talking about here is a 227 foot, that's 70-metre boom, 22,000 litre sprayer. So same format, base format, but then it becomes a toolbar that everything else bolts onto. So that's a pretty massive sprayer. So one of the things that the Nexat team has done is partnered up with other manufacturers to, I guess, develop the tools that bolt to their toolbar. And in this case, we've got Vaderstead, both tillage and also seeding equipment. And one of the units that they've got running around, or there's a pair of units running around with 28 Vaderstead precision row units at 50 centimetre spacings. I understand that these two are operating in some part of the Ukraine, and interestingly enough, you'll also note that these two machines are running on wheels, not tracks like the other units that we've shown. So yeah, just demonstrating, I guess, some more versatility in that respect. And to complete the picture here, a harvester using a Geronoff front. It's a pretty impressive machine. What we're talking about is 130 to 200 tonnes an hour, a 5.8 metre axial rotor mounted in the transverse plane. The grain bin, 36,000 litres and 600 litres a second outload. So yeah, different format, different way of thinking about it, and obviously some pretty huge horsepower that generates quite a bit of productivity. So it'll be interesting to see how this, I guess, format evolves. So Nexat aren't the only people working on, I guess, an alternative gantry style format. Here we've got the RO24G from Horsch that's only just been released, and in fact this unit is apparently off to Brazil to do some soybean work. But what you'll notice is that we're employing both that alternative, almost gantry sort of style format, but in this case pairing it up with Autonomy as well. And knowing Horsch, knowing that they develop a whole heap of gear, including sprayers, I wouldn't be surprised if we see something come from them in the not too distant future that maybe has some spray equipment on it as well, utilising that sort of common toolbar platform that they've employed here with the RO24G. So that brings us to the end of what I'd hope to talk to you about today, and we'll head off to some questions. So with that, we'll throw it open to the gods of technology, and I'll hopefully jump on a Zoom and be able to take any questions. So if you've got any questions you've jotted down, feel free to ask me now, and I'll have a crack at either answering them or making something up that sounds plausible. My contact details are there as well if anyone wants to get in touch.
Thank you so much, Ben. That's a great way to finish the day, because I know everyone loves to look at the machinery and certainly what's coming up. I still want one of those little Fendt tractors that you show at the front. That's one of my things. Question from Dan at the front.
Hey Ben.
Yep.
Hey Ben, Daniel Birch here. Ben, I was speaking to a dealer just recently about green on green, and they were saying that every second sprayer quote they're putting out is with green on, and it's being picked up a lot in the northern ag region. What are your thoughts on where it's at with commercialisation and reliability?
I think it'll continue to evolve. I think it's probably demonstrated reasonable reliability already, particularly in that northern ag region. I think there's probably some owners there that have worked pretty hard with manufacturers to help that process, and I think we've got to acknowledge the growers that are investing that time, because ultimately it's for the good of the industry. So look, I think, Dan, that as I said before, there's going to always be an evolution. Are you going to be at the bleeding edge still? Possibly, yeah. But you've also got some large players coming through that'll both encourage competition and also foster more rapid development. So I can see why the technology, the quotes are being done that way, because the technology is there. The actual hardware is probably not going to change too much, but the algorithms that sit behind it may. So yeah, that'll be where the evolution happens.
We'll go to Rod.
Yeah, hi Ben, Rod Birch, Carew. You're getting the whole family at you. Hey Ben,
I am, mate.
what seems to be a big lag between the mining industry and ag industry is not so much electrification and rechargeable, but diesel electric, because like haul packs, everything, that's all they're running around everywhere. What has been the lag there between diesel to electric drives when to do away with a lot of the inefficiency of hydraulics?
Yeah, it's a good point, Rod. I'm not sure why the lag. I think obviously that's starting to change now, and when you see large manufacturers like Deere coming out with this EVT, I see that as a step in the right direction to sort of changing that. And you're right, locos and haul packs have been using diesel electric for a long time. Caterpillar had a bulldozer that was, or still have a bulldozer that is diesel electric. It makes a lot more sense in terms of being able to transfer that mechanical energy to ground, and so why? Probably cost and volume, I suspect. I'm not sure whether providing a cheaper transmission option in bulk might have been the way that it's been done traditionally, and so that's what people are used to. So but like I say, I think that's starting to evolve now, and I think we can probably look forward to some of the benefits that the likes of diesel electric will bring us, with I guess the forward compatibility potentially of swapping out the diesel for something like a fuel cell, or albeit batteries, whatever might evolve to suit our needs.
Great. Will in the middle?
Ben, just continuing for that question, I've got a hybrid RAV4, and not as efficient as I hope. What type of fuel saving are you looking over diesel electric versus pure diesel? And is it worth doing that step, or is it better just to wait another 5 or 10 years for a pure electric? Is that going to be viable?
Look, I think. Yeah, so the issue with the RAV, it sounds like it might be your right foot. I'm not sure. I'm just guessing, but I think one of the issues that we were seeing is that we are sort of still evolving some of this, and regardless, like a diesel electric system is definitely much more efficient. There's not as much heat generated. There's not as much energy wasted in that transmission system as it is in hydraulics or mechanically even. So it is a more efficient way of transferring, I guess, the energy through the wheels, which is where we need them. So ultimately, you are going to get efficiencies. Being able to quantify those at this stage is pretty tricky. I hear numbers thrown around 10-15%. How much credence we can give those, I'm not totally sure. The proof will be in the pudding once we've got the gear here. But I think as you found with the RAV4, there's probably again the market is at play a little bit in terms of what's promised and what reality is.
Hang on, down the back.
Did anyone ever come up with a system of on-the-go soil testing linked to variable rate seeding technology?
Yeah, so there's a couple of things kicking around at the minute with on-the-go soil sampling, and I've seen a few developments in that space. We also saw some at Agritechnica that employed different sensor technology. Yes, it is out there. I guess my question is just how accurate is it? And I suppose the best way to do any analysis of that is to ground test, ground truth it. So testing those systems is something that we've got on our Kondinin Group list of things to look at. And I know there's a few being thrown around at the minute. I've seen some press releases, etc., that have made some suggestions as to what might be up and coming. We'd be really keen to have a look at those, because if they work, I think that's really exciting. But again, we just don't want that marketing to get ahead of things. We want to make sure that they're actually going to tell an accurate picture, because if we're making big calls on fertiliser placement or rates based on information coming from those, we want to make sure they're right.
Okay, I think we've run out of questions from the floor, Ben. I do look forward to the days when we have little swarms or bigger swarms running around at night time doing all the work, and then everyone can just wake up and it's all done in the morning.
Absolutely.
Yeah. I would like to thank and join with me in thanking Ben for joining us from, where were you? West Wyalong.
Yeah, West Wyalong, you know, if you want a holiday, guys, this is the place to come. So, yeah, it's a little bit wet here. I understand you guys had a little bit of wet as well. I think I had to drive through 400 mils of water to get here. So, yeah, I share your pain.
Well, it sounds like you did travel to Moora, because we've had a lot of rain and the road was closed from Perth. So, yeah, thanks so much for coming in, Ben. It's been great, as always.
Thank you. Thanks, guys.
That has...